Hello again. Now that we have grasped the fundamental concepts of the CIA triad, the AAA model, and other core security concepts, let's apply these ideas to the world of web applications. Picture this, a typical web application architecture. On your left, we have a web client. This could be any device using a web browser like Google Chrome or Firefox. And this will be the client used by the end user to access our system. Then we come across the firewall, the gatekeeper of our network. The role of the firewall here is to filter the requests sent from the web client. We will see afterwards how the firewall works and how it can improve the security of our system. Beyond that firewall, we have a web server. And it could be something like Nginx or Apache or any other web server, which is managing communications with different web applications. These web applications might be designed using frameworks like Spring Boot for Java or Express.js for Node.js. And that's the core of our system. And we could imagine, for example, exposing REST APIs thanks to these web applications. Finally, the web applications themselves communicate with databases, which could be something like MySQL or MongoDB to persist all the data handled by the system. So, if we go back to the firewall, we can see that it has two specific openings or ports, which are meant for HTTP and HTTPS traffic. The ports are 80 and 443, the standard ports for these types of internet traffic. So for those who don't know, HTTP stands for Hypertext Transfer Protocol, which is the foundation of any data exchange on the web. And if you access any website on the internet like Google or Facebook, it will be thanks to HTTP and HTTPS. HTTPS or HTTP Secure is the secure version of HTTP, where communications are encrypted by Transport Layer Security or TLS. Later in this course, we will have a specific detailed section that explains how TLS works in real life. Now, let's go back to ports. And in this context, ports are like endpoints in the operating system where network connections start or end. They are associated with a specific service that the server offers, and in this case, the HTTP or HTTPS service. So, when we say that the firewall has specific openings for HTTP and HTTPS traffic on ports 80 and 443, we mean that it allows data to be exchanged via these protocols through these particular endpoints. Now let's take a closer look at the firewall. So, a firewall is a crucial part of network security. It monitors and filters the incoming and outgoing network traffic based on a set of security rules. It's like a barrier between a network that we trust, our own, and a network that we don't, which is the internet. And firewalls can be a dedicated hardware device, a software program, or often a combination of both. And as shown in the diagram, the firewall is blocking requests from certain protocols such as FTP, Telnet, and NetBIOS, while allowing HTTP and HTTPS requests to pass through. However, it is important to understand the limitations of a firewall. So, a firewall is enabled to protect against vulnerabilities in the transported application protocols. So, to make it more clearer, the HTTP and HTTPS ports, which are open for communication, can be used to encapsulate and transport data to and from application platforms. And this exposes a potential chain of vulnerabilities at different levels of our architecture. Now let's go back to our diagram. At the web client level, there could be vulnerabilities to attacks like cross-site scripting or XSS. The web server, something like Nginx, for example, might be vulnerable to misconfiguration or URL interpretation issues. Our web applications, whether built with Spring Boot or Node.js or another platform, might be open to problems from poorly validated user inputs. And finally, at the database level, we could potentially face SQL injection attacks. And this illustrates the importance of understanding and addressing vulnerabilities at all levels, a concept that's deeply tied to the principles of the CIA Triad and the AAA model that we have already discussed. Now, let's introduce another critical concept in network security, the DMZ, or Demilitarized Zone. This term might sound like it's straight off a war movie, but in our context, it refers to a physical or logical subnetwork that acts as a buffer between an internal local area network, LAN, and another untrusted network like the internet. So the purpose of a DMZ is to add an extra layer of security by segregating critical internal systems from external access. And this reduces the potential exposure of these systems to attacks. So take a look at this diagram. You will see the DMZ sandwiched between the untrusted network, say the internet, and the highly secured area, HSA, which is our internal network. So one of the keys to leveraging a DMZ effectively is through careful deployment patterns. By strategically placing systems within the DMZ, we can ensure that even if an attacker breaches the outer network defenses, they still wouldn't have immediate access to critical internal resources. As an example, we might place our web servers, which need to be accessible from the internet obviously, within the DMZ, and our databases, which contain sensitive information and sensitive data, within the highly secured area, providing a robust layered defense that aligns with our previous discussion of the CIA Triad and the AAA model. So, as we have seen, understanding the structure of a web application architecture and its potential vulnerabilities is a crucial step in securing our systems. And this includes understanding how components like firewalls and DMZ work together to defend against external threats. However, this understanding wouldn't be complete without delving into the most common security risks that web applications face today. And for this, we turn to the OWASP Top 10. So, OWASP stands for Open Web Application Security Project. It is an online community that produces freely available articles, methodologies, documentation, tools, and technologies in the field of web application security. Their Top 10 is a standard awareness document that represents a broad consensus about the most critical security risks to web applications. In our next section, we will dive into each of these risks, understanding what they are, how they work, and most importantly, how we can mitigate them. So, be ready to dive into the world of OWASP and the top 10 security risks for web applications, and see you in the next section.